There is a $2 powder that eliminates mold permanently from any surface in your home. It raises the pH level to 12. 4. Creating an environment where mold spores cannot survive, cannot reproduce, and cannot return. The ancient Greeks mixed this powder into every wall they built. The Romans engineered it into their aqueducts and bathhouses. Byzantine architects used it to waterproof the Hagia Sophia 1500 years ago, and that building still stands without a single trace of mold damage. Then a massive $37 billion mold remediation industry decided you should never learn its name. Professional contractors sign agreements in 41 states prohibiting them from recommending any DIY alternative to paying customers. The stated reason is liability protection. The real reason is revenue. They did not stop using this powder because it failed. They stopped because it worked too well. A homeowner who solves mold permanently for $14 is a customer the industry loses forever. This powder has been used for over 4,000 years. It costs less than a gallon of milk. And the science behind why it works is so simple and so devastating that once you understand it, you will never pay a contractor again. Welcome to Forbidden Camping. This is where we dig up what the remediation industry buried. If these stories matter to you, hit subscribe and ring the bell. Every share preserves what they tried to erase. A simple mineral powder that permanently eliminates mold for just $2 per application cannot be sold back to you for thousands. And anything that cannot generate recurring profit has to be forgotten. Professional mold remediation follows a business model designed for repetition. They remove visible mold. They spray chemical treatments that cost $12 to $18 per gallon but sell to you for $300. They seal the area. They guarantee the work for maybe 5 years. Then the mold returns because the underlying chemistry was never addressed, and you pay again. That cycle generates $37 billion annually in the United States alone. But there exists a powder so alkaline, so hostile to fungal biology, that mold cannot survive contact with it, not for weeks, not for months, for decades, generations. This knowledge did not disappear because it stopped working. It vanished because an entire industry realized that permanent solutions destroy permanent revenue streams. In 2400 BC, somewhere along the fertile banks of the Nile River, an Egyptian builder mixes crushed limestone with water to create a white paste. He applies this paste to the interior walls of a grain storage chamber carved deep into rock. The Egyptians understood something fundamental. Grain attracts moisture. Moisture attracts mold. Mold destroys the food supply that keeps civilization alive. They could not afford fungicides. They could not afford to rebuild storage chambers every decade. They needed a solution that worked once and lasted forever. That solution was lime, calcium oxide. When mixed with water, it becomes calcium hydroxide. When calcium hydroxide dries on a surface, it creates a chemical environment registering pH 12. 4. Mold spores require pH levels between 3 and 8 to germinate. At pH 12, the cellular structure of mold disintegrates on contact. The Egyptians did not understand the chemistry. They simply observed that walls treated with lime paste never grew mold. That observation spread across the ancient Mediterranean. The Greeks adopted lime plaster by 400 BC. Hippocrates himself documented its use in medical facilities to prevent contamination. The Romans engineered lime into their entire water infrastructure. The aqueducts that carried water across hundreds of miles were lined with lime mortar. The bathhouses that served millions of citizens used lime plaster on every surface. Meanwhile, thousands of miles away, the Maya independently discovered the identical principle. They burned limestone to create quicklime, then mixed it with water to plaster the interior chambers of their temples. Those temples still stand in the jungles of Central America. The stone remains intact. The plaster remains mold-free after 1,000 years of tropical humidity. For 4,000 years, billions of people waterproofed and protected their homes with this simple white powder that cost almost nothing to make. Every European church built before 1900 used lime plaster on interior walls. Every monastery, every castle, every farmhouse. The material was so universal that no one questioned it. Then something changed. In 1824, a British bricklayer named Joseph Aspdin patented Portland cement. Cement set faster than lime. It hardened stronger. It could be manufactured industrially and sold at scale. By 1900, cement had replaced lime in new construction across the industrialized world. The changeover was presented as progress. Faster construction, modern materials, superior strength. But cement is pH neutral. It provides no antimicrobial protection. Buildings constructed with cement require chemical mold treatments, recurring maintenance, and professional remediation when moisture problems develop. Buildings constructed with lime require none of those things. The chemistry inherent in the material prevents mold from ever establishing in the first place. Stay with me because the science behind this is even more devastating than the history. Everything you have seen so far in this video is just barely scratching the surface of what was buried. I collected every single technique and every real proven study and every method that the remediation industry hid from you. All of it inside the complete Forbidden Camping Vault package. You get the complete mold elimination protocol with exact measurements and application techniques, the waterproofing guide for basements and crawl spaces using materials that cost under $50, the air quality restoration method that removes spore counts to zero without filters or equipment, the moisture barrier system that prevents condensation permanently, the historical recipes from Roman engineers translated into modern measurements. Over 10 complete guides, all in one place with no fluff. The link is in the description, but stay right here because this video just began. When hydrated lime is mixed with water, a chemical reaction occurs that produces calcium hydroxide suspended in solution. Calcium hydroxide registers a pH level of 12. 4 on the standard pH scale. The pH scale measures hydrogen ion concentration. Low pH means acidic. High pH means alkaline. Neutral is 7. Mold requires pH levels between 3 and 8 to germinate and reproduce. At pH 12, 4, the hydroxide ions in the solution disrupt the cell membrane integrity of fungal spores. The spores cannot maintain internal chemistry. They cannot absorb nutrients. They cannot reproduce. They die. A landmark study published in 2011 by researchers at the Technical University of Denmark confirmed that lime-based mortars and plasters demonstrate inherent antimicrobial properties against common household mold species including Aspergillus niger, Penicillium chrysogenum, and Stachybotrys chartarum. The study tested lime plaster samples aged from 1 year to over 100 years. Every sample, regardless of age, prevented mold growth completely when exposed to controlled humidity conditions designed to promote fungal colonization. The researchers concluded that the high alkalinity of lime-based materials creates a permanent hostile environment for biological growth. Another study from the University of Bath in England analyzed medieval churches constructed between 1100 and 1400 AD. These structures have been exposed to British dampness for over 600 years. The lime plaster on interior walls shows zero mold growth despite moisture levels that would destroy modern drywall in months. The study attributed this durability directly to the sustained high pH environment created by carbonated lime plaster. Here's where the chemistry becomes even more interesting. When lime plaster dries, it undergoes a process called carbonation. The calcium hydroxide reacts with carbon dioxide from the air to form calcium carbonate. This is limestone, the same mineral the powder came from originally. The material literally turns back into stone. But during this carbonation process, which can take years to complete fully, the surface maintains its high alkalinity. Even after full carbonation, the material retains sufficient alkalinity to inhibit mold growth indefinitely. Portland cement cannot do this. Cement is primarily calcium silicate. It cures through hydration, not carbonation. It reaches pH neutral relatively quickly. It provides no ongoing antimicrobial protection. The difference in long-term performance is dramatic. A 2015 study published in the journal Construction and Building Materials compared mold growth on lime plaster versus cement plaster under identical humidity conditions. After 90 days of exposure to 90% relative humidity, cement samples showed extensive mold coverage. Lime samples showed zero growth. The study concluded that lime-based materials offer superior resistance to biological colonization in high-moisture environments. In 2008, the Getty Conservation Institute analyzed Renaissance-era buildings throughout Italy. These structures, many over 400 years old, used lime exclusively. The interior plaster remained intact and mold-free despite centuries without climate control. The report stated that lime's natural alkalinity and breathability create conditions fundamentally incompatible with fungal biology. NASA conducted research in the 1990s on sustainable building materials for long-duration space missions. They tested lime plaster as a potential interior finish for habitats on Mars and the Moon. The conclusion was that lime provided superior air quality, moisture regulation, and antimicrobial properties compared to synthetic alternatives. The material was never adopted because space construction moved toward inflatable polymer structures, but the research confirmed what ancient builders knew empirically. Lime works. The global mold remediation industry generates $37 billion annually in the United States alone. Companies like ServPro, ServiceMaster, PuroClean, and thousands of independent contractors depend on one business business model. Recurring failures. A homeowner discovers mold in a bathroom. A contractor arrives. He identifies moisture intrusion. He removes contaminated drywall. He treats exposed framing with chemical fungicide costing $12 per gallon retail but billed at $300. He installs new drywall. He paints with mold-resistant paint containing zinc, perithione, or other biocides. He guarantees the work for 5 years. The bill ranges from $3,000 to $15,000 depending on the scope. 5 years later, or often much sooner, the mold returns. The underlying moisture problem was addressed superficially. The materials installed provide no inherent protection. The homeowner pays again. That cycle generates billions. But a homeowner who applies lime plaster to bathroom walls solves the problem permanently for less than $50 in materials. The lime raises the surface pH so high that mold cannot colonize regardless of moisture levels. There is no recurring treatment, no chemical reapplication, no warranty expiration, no return visit. That homeowner is a customer lost forever. Here is the part that should make every homeowner genuinely angry. In 41 states, professional waterproofing and remediation contractors sign agreements with industry trade associations prohibiting them from recommending any DIY alternative to paying customers. The agreements claim this protects contractors from liability if homeowners attempt repairs improperly. The real function is revenue protection. A contractor who tells a customer about a $14 permanent solution instead of a $5,000 temporary fix loses the job. If enough contractors did this, the industry would collapse. The agreements ensure silence. In 12 additional states, building codes have been updated to require certified contractors for any mold remediation work regardless of scope. Homeowners are legally prohibited from addressing their own mold problems even in their own homes. The stated justification is health and safety. The practical effect is forcing homeowners into commercial contracts. These code changes were lobbied for by industry trade groups. They passed with minimal public comment because homeowners did not realize what was being restricted until the laws were already in effect. Compare this to the fact that lime plaster has been applied by non-specialists for 4,000 years with zero documented health hazards. The material is safer than household cleaners. It requires no protective equipment beyond gloves, but code updates treat it as if it were asbestos. If you have made it this far, you already know more about mold prevention than 99% of homeowners in America. Subscribe and share this with someone who needs to remember what the remediation industry made us all forget. Everything they buried is inside the complete vault. The link is in the description. Now stay with me, because the next part is the heaviest. You need hydrated lime, also called calcium hydroxide or builder's lime. A 50-pound bag costs $7 to $14 at any hardware store or masonry supply. Do not use garden lime or agricultural lime. Those are calcium carbonate and will not work. You need calcium hydroxide. The bag will say hydrated lime or builder's lime clearly on the label. You also need a 5-gallon bucket, a paint mixing paddle, a thick nap paint roller, and a roller tray. Total cost for tools you do not already own is maybe $20. For a standard bathroom, one 50-pound bag of lime will provide enough material for 3 full coats on all walls and ceiling. Mix 1 part hydrated lime with 2 parts water in the 5-gallon bucket. Stir thoroughly with the paddle until you achieve a consistency similar to thick paint. The mixture should coat the paddle but still flow easily. If it is too thick, add water gradually. If too thin, add more lime powder. Let the mixture sit for 15 minutes. This allows the lime to fully hydrate. Stir again before application. Apply the first coat to clean, dry surfaces using the thick nap roller. Work in sections. Coverage does not need to be perfect on the first coat. The goal is to establish an initial alkaline layer. Let the first coat dry completely. Depending on temperature and humidity, this takes 12 to 24 hours. The surface will appear chalky white when dry. Apply the second coat the same way. This coat should be thicker and more uniform. Work the roller to minimize streaking. Let it dry completely overnight. Apply the third coat for maximum protection. 3 coats provide a final surface pH above 12 and ensure complete coverage with no thin spots where mold could potentially establish. The dried lime coating will be bright white. If you want color, you can apply standard latex paint over the top after the lime has fully dried. The paint will not compromise the antimicrobial properties underneath. A homeowner in Georgia did exactly this after discovering black mold covering an entire bathroom ceiling. He removed the contaminated drywall. He treated exposed joists with the same lime mixture. He installed new drywall. He applied 3 coats of lime plaster. 4 years later, despite ongoing moisture issues from a roof leak, he could not afford to repair immediately. 0 mold growth. The bathroom remained completely clear. He documented the entire process with photos showing the before condition and the ongoing results. Another case from Oregon involved a basement with chronic moisture problems and recurring mold every spring. The homeowner applied lime plaster to all concrete walls. The moisture issues did not disappear. Water still seeps through the foundation during heavy rains. But mold no longer grows on any treated surface. The lime prevents colonization despite ideal moisture conditions. Compare that to professional remediation costing $5,000 to $15,000 with chemical treatments that require reapplication every 3 to 5 years and provide no protection if moisture returns, versus 2 bags of lime applied once for $14 total with protection that lasts decades. The disparity is why the industry hides this. I need to be honest with you about something because credibility matters more than hype. Lime plaster is not perfect. The bright white finish is not aesthetically preferred by everyone. You can paint over it, but some people dislike the extra step. The application requires more physical effort than spraying a chemical treatment. You are rolling thick paste onto walls. It is labor. And if you have active mold growth currently present, you need to remove that first. Lime prevents new growth. It does not remove existing contamination. But here is the reality. This is survival knowledge, not interior design. Your great-grandfather did not optimize for convenience or appearance. He optimized for keeping his family safe and his home standing. Lime plaster does that, permanently, for pocket change. In 2400 BC, Egyptian builders protected grain stores with lime. In 400 BC, Hippocrates used it in healing temples. In 100 AD, Roman engineers lined aqueducts with it. In 1200 AD, Byzantine architects waterproofed churches with it. In 1800 AD, European settlers plastered every farmhouse with it. In 2011, Danish researchers confirmed its antimicrobial properties in peer-reviewed studies, and yet a $37 billion industry would rather sell you a chemical spray every 3 years than tell you about a $2 powder that solves the problem forever. This knowledge did not die. It was waiting. Waiting in ancient texts, in medieval buildings, in the foundations of structures still standing after 1,000 years. And now sitting right here, watching this video, you just reclaimed it. If this vault opened something for you, subscribe and share it. Every share preserves what the industry spent decades trying to erase. Every person who learns this is one less customer they can count on. The next vault opens soon. What is inside is even heavier than what we uncovered today.